Today we are going to discuss Cheteliers principle. Now, we know that when a chemical reaction is in a state of equilibrium, the temperature, pressure or concentration of that reaction remains constant. Now, if we make a small change in the temperature, pressure or concentration of the reaction, then the equilibrium will get disturbed. So, what happens when we change the temperature, pressure or concentration of a reaction which is at equilibrium? I told the equilibrium will get disturbed. Now, this is explained using Cheteliers principle. Now, first let's see the statement of Cheteliers principle. The Cheteliers principle states that if we change either concentration, temperature or pressure of a system at equilibrium, the system adjusts itself to nullify the effect of that change. So what happens is, when we change the temperature, pressure or concentration of a reaction which is at equilibrium, the reaction will try to cancel the effect of that change, or it tries to nullify the effect of that change. Nullify means cancel. Somehow the reactants and products tries to cancel that change in concentration, temperature or pressure, and finally the equilibrium is re-established. So this is the statement of Cheteliers principle. That is, if we change concentration, temperature or pressure of a system at equilibrium, the system adjusts itself to nullify the effect of that change. Now, there are four factors that affect the equilibrium reaction. They are concentration, temperature, pressure and presence of catalyst. So we are going to study in detail each of these factors, how these factors will cause a change in the state of equilibrium. So first let's discuss the effect of change of concentration. So the first factor is effect of change of concentration. To study the effect of change of concentration on a reaction at equilibrium, let's take an example, a general equation A plus B in equilibrium gives C plus D. Now A and B, they are the reactants, and C and D are the products. So this reaction is at equilibrium now, and you know the forward reaction is A and B reacting to give the products C and D, and we have the backward reaction in which C and D react to give the product A and B. Now suppose I increase the concentration of any one of the reactant. Here the reactants is A and B. So I increase the concentration. Increase the concentration of either A or B, any one of the reactant. What will happen? So this reaction was at equilibrium. Now I increased the concentration of the reactant A or B. Now the equilibrium is disturbed because there is more concentration of the reactant. So what will this system do? According to Cheteliers principle, now the system will try to nullify the effect of that increase in concentration of the reactant. So what will happen? Since I increased the concentration of the reactant, the reaction will take place in forward direction, means more and more product will be formed, and the reaction takes place in forward direction so as to reduce the increased concentration of the reactant. and finally the equilibrium, a new equilibrium is re-established. Now, so in this case, if I increase the concentration of A or B, the reaction takes place in which direction? It takes place in forward direction. Now, suppose I increase the concentration of C and D. Increase the concentration of C and D. Now again the equilibrium is disturbed, so what will happen? The reaction will take place now in the backward direction because there is more concentration of C and D. So C and D will react to form A and B. So the reaction takes place in the backward direction so as to reduce the increased concentration of C and D. So here if I increase the concentration of C and D, the reaction takes place in backward direction. Now I'll give an example. Example is the formation of ammonia molecule. The reaction is nitrogen gas plus 3H2 hydrogen gas. Equilibrium, we get 2NH3 ammonia gas. Now here you can see nitrogen and hydrogen are the reactants and they give the product ammonia, that is the forward reaction, and the backward reaction is the decomposition of ammonia to form nitrogen and hydrogen gas. Now in this reaction, to get maximum yield of ammonia, to get maximum yield or amount of ammonia, what is it? How can I do with the concentration? I should increase the concentration of the reactants, either nitrogen or hydrogen. So to get maximum yield of ammonia, we have to increase the concentration of nitrogen gas or hydrogen gas. Okay, so if I increase the concentration of nitrogen gas or hydrogen gas, the reaction will proceed in forward direction, resulting in the formation of more and more amount of ammonia gas. So this is the effect of concentration on equilibrium. Now next factor is temperature. So let's see the effect of change of temperature. Second one, effect of change of temperature. Now, the effect of change of temperature on the equilibrium constant depends on the sign of delta H. So, the effect of change of temperature depends on the sign of delta H. Delta H means enthalpy change. Enthalpy means energy. Now, in this case, it is the heat energy. Okay, so delta H can be positive or negative. Now, when we consider an equilibrium reaction A plus B in equilibrium with C plus D, we know that there is a forward reaction and a backward reaction. Now, if the forward reaction is exothermic, then the backward reaction will be endothermic. And we know exothermic reaction means heat is released and endothermic reaction means heat is absorbed. So exothermic. What are exothermic reactions? Reactions in which heat is released. And endothermic reactions means heat is absorbed. So I said for a reaction at equilibrium, we have a forward reaction and a backward reaction. So if one of the reaction means if the forward reaction is exothermic, then the backward reaction will be endothermic. Now, if the forward reaction is endothermic, then the backward reaction will be exothermic. Okay, now let's see how is the value or sign of delta H decide the effect of change of temperature. Now, I am going to write something. exothermic reactions, heat is released, delta H is negative, and this is favored at low temperature. Very important point. Now next I am going to write the next important point. Endothermic reaction means heat is absorbed, means delta H is positive and favored at high temperature. These 2 points are very important points. So if you study this box, you can easily predict the effect of change of temperature on equilibrium of a reaction. So I told you, it's for an equilibrium reaction, if the forward reaction is exothermic, the backward reaction is endothermic, and if the forward reaction is endothermic, backward reaction will be exothermic. So if you look at the sign of delta H, you can predict whether the forward reaction is exothermic or endothermic. So if the delta H value is negative, then the forward reaction is exothermic. Now, exothermic reaction means heat is released, and exothermic reactions are favored at low temperature, or exothermic reactions take place at low temperature. Now, if the forward reaction is exothermic, then the backward reaction will be endothermic. Endothermic means the value of delta H will be positive and heat is absorbed, and endothermic reactions are favored at high temperature, or endothermic reactions take place at high temperature. Now let us see 2 examples. The first example, to study the effect of change of temperature. Example 1. Consider the reaction N2 plus O2 in equilibrium gives 2NO, and the delta H value for this reaction is 180 kilojoule per mole. Now, here nitrogen gas plus oxygen gas, all the reactants are in gaseous state, gives nitric oxide. NO is nitric oxide, and the value of delta H is given as 180 kilojoule per mole. 180 kilojoule per mole means it is plus, positive. So we know if delta H is positive, then the forward reaction is endothermic. So which is the forward reaction here? N2 plus O2 giving 2NO. The forward reaction is endothermic. Now, if the forward reaction is endothermic, then what about the backward reaction? Backward reaction means decomposition of nitric oxide to nitrogen and oxygen gas. That will be exothermic. And I told endothermic reaction takes place at high temperature. So this reaction is now at equilibrium. Now what I am going to do is, I am going to increase the temperature of this reaction. So when I increase the temperature of this reaction, what happens? The reaction will proceed, or the reaction shifts to the side which absorbs heat. Now in this case, the reaction, the forward reaction is endothermic, means absorption of heat. So I have increased the temperature. So here for this reaction, if I increase the temperature, the reaction will take place in forward direction to reduce that increased temperature. Okay, and if I decrease the temperature, then the reaction will proceed in backward direction. So for this reaction, if increased temperature will result in forward reaction, because forward reaction is endothermic. And if we decrease the temperature, then backward reaction takes place, because we know the exothermic reaction takes place at low temperature. So if I decrease the temperature, since the backward reaction is exothermic, the backward reaction takes place in this case. Now let's see the next example. And finally, what happens to this after moving in forward and backward direction? An equilibrium is re-established. Now next see the second example to study the effect of change of temperature. Example 2 is again the formation of ammonia, nitrogen gas plus hydrogen gas. Equilibrium gives ammonia gas, and the value of delta H for this reaction is delta H is minus 46.1 kilojoule per mole. Now you can see the delta H value in this case is negative, minus 46.1. So what do you understand? For this reaction, the forward reaction is the formation of ammonia from nitrogen gas and hydrogen gas is exothermic. So the forward reaction is exothermic, and that forward reaction takes place at low temperature because exothermic reactions take place at low temperature. And the backward reaction in this case is the decomposition of ammonia to nitrogen and hydrogen gas. That will be an endothermic reaction, and it takes place at high temperature because endothermic reaction takes place at high temperature. So to get maximum yield of ammonia, the temperature must be low. It must be very low, only then the forward reaction takes place and we get ammonia. So this is a condition to get maximum yield of ammonia, that is low temperature will give maximum yield of ammonia. So when you manufacture ammonia gas, this is one of the very important condition that is to be noticed, that is low temperature favors the formation of ammonia gas because the delta H value is negative. So forward reaction is exothermic, and exothermic reactions take place at low temperature. Now backward reaction is endothermic, means decomposition of ammonia into nitrogen and hydrogen gas takes place at high temperature. So low temperature will give maximum yield of ammonia, and high temperature favors decomposition of ammonia. Because backward reaction is endothermic and it takes place at high temperature. Now this reaction is at equilibrium. Suppose I increase the temperature of this reaction. What will happen? The equilibrium gets disturbed. Now what will happen? What will the equilibrium do? The equilibrium will try to shift in that direction which absorbs heat. So here in this reaction I have increased the temperature. I have supplied the temperature. So the reaction will try to lower that increased temperature by absorption. And we know in this case it is the backward reaction which is endothermic. So when I increase the temperature for this reaction, which reaction will take place? The backward reaction will take place. So if on increasing the temperature for this reaction, the backward reaction takes place. Reaction takes place. And if I decrease the temperature, then the forward reaction takes place, because when I decrease the temperature, the reaction will shift in the direction in which heat is released. So forward reaction takes place. On decreasing the temperature, forward reaction takes place. Okay, so This is the effect of change of temperature on equilibrium of a reaction. Now, next, third factor, that is the effect of change of pressure on equilibrium of a reaction. So, the third factor, number 3, effect of pressure. Now, this effect of pressure is applicable, or it is significant in case of gaseous reactions, means if the reactants and products are in gaseous state. So, I am going to write again the example, that is the formation of ammonia molecule. So, the reaction is example 1. The reaction for the formation of ammonia molecule is N2 gas plus 3H2 gas in equilibrium to NH3 gas. Now here what we have to see is the number of moles of reactants and products, total number of moles of reactants and products. And to find the number of moles of reactants and products, we have to look at the stoichiometric coefficient. And you know, where is the stoichiometric coefficient written? It's written on left hand side before the symbol. So here nitrogen, the stoichiometric coefficient, nothing is written, means it is 1, plus what is the stoichiometric coefficient for hydrogen? 3. So 3 plus 1, we have total 4 moles on reactant side, and product we have 2 moles of ammonia. So to study the effect of pressure, first you have to check the number of moles of reactants and products. Now you can see in the forward direction the number of moles decreases, which means in the backward direction the number of moles increases. So forward direction the number of moles decreases from 4 to 2, backward direction it increases from 2 to 4. Now I am going to write something, that is again 2 important points. Low pressure favors reactions accompanied by increase in total number of moles. So, if there is an increase in total number of moles, then pressure decreases. So, if you look at this reaction, you can see in the forward direction, the total number of moles decreases, and in backward reaction, the total number of moles increases. So, I told if there is an increase in total number of moles, then low pressure is favorable, which means here for this reaction, low pressure favors the backward reaction. Now next I am going to write the next point, high pressure favors reactions accompanied by decrease in total number of moles. So again, these 2 points are very important to study the effect of pressure. Okay, which means the meaning of the second point is when the total number of moles decreases, high pressure is favorable. So you can see in this reaction, in the formation of ammonia molecule, the total number of moles decreases in forward direction. So high pressure favors the forward reaction, which means high pressure favors the formation of ammonia molecule. Or we can say when you manufacture ammonia, high pressure is required for the formation of ammonia gas. Okay, because in the forward reaction the number of moles decreases. So that's a very important point to be noted. That is high pressure favors formation of ammonia. And when we discussed the temperature, we discussed low temperature favors the formation of ammonia. Now, these are the 2 important conditions to get maximum yield of ammonia, which is which are the two conditions, low temperature and high pressure. Okay, now these 2 points are to be noted. So we understood what is the effect of pressure on equilibrium of a reaction when high pressure will favor reactions accompanied by decrease in total number of moles, and low pressure favors the reaction accompanied by increase in total number of moles. Now suppose I increase, now this reaction is at equilibrium. Now I increase the pressure of this reaction. What will happen? The equilibrium will get disturbed. I increased the pressure. Now what will the equilibrium do? It will try to shift in that direction in which the total number of moles decreases. So here when I increase the pressure, which direction the reaction takes place? In forward direction, so as to reduce the total number of moles. Now if I decrease the pressure, what will happen? The reaction will take place in that direction in which the total number of moles increases. So if I decrease the pressure, then the backward reaction takes place. So this is the effect of change of pressure on equilibrium reaction. Now I am going to give another example, second example, example 2. PCl5, equilibrium with PCl3 plus chlorine, all in gaseous state. Now in this case we can see, first let's write the total number of moles. Here reactant we have only 1 mole and product we have 1 plus 1, total 2 moles. So the forward reaction, we know the number of moles increases, which means low pressure. If the number of moles increases, then low pressure favors the forward reaction, and backward reaction, the number of moles decreases from 2 to 1. So high pressure favors the backward reaction. So in this case, forward reaction is favored at low pressure and backward reaction is favorable at high pressure. Okay, now there is another example, that is example number 3. That is N2 plus O2, equilibrium 2NO. Now in this case the total number of moles of reactant is 1 plus 1, which is equal to 2 moles, and the product is 2 moles. Now in this case the total number of moles of reactants and products remains the same, there is 2 moles and 2 moles. So if the total number of moles remains the same, then we say that pressure has no effect on the equilibrium of this reaction. So here pressure has no effect because the total number of moles of reactants and products remains the same. So this is the effect of pressure on equilibrium of a reaction. Now the fourth factor is effect of catalyst, number 4. You know, catalysts, they help to increase the rate of a chemical reaction. So this catalyst, if present in the reaction, it does not change the state of equilibrium. The reaction will be at equilibrium, does not make any change to that equilibrium condition, but it helps to increase the rate at which that equilibrium condition is reached. So this presence of catalyst will help to attain equilibrium stage faster, but it does not make any change to that equilibrium condition. So these are the 4 factors that affect the equilibrium of a chemical reaction. Now next we have a question. The question is, describe the effect of, there are 5 questions A, B, C, D, E on the equilibrium of the reaction, and I have written the equation here. 2H2 gas plus CO gas gives CH3OH. CH3OH is methyl alcohol or methanol, all in gaseous state. Now the first question is describe the effect of addition of hydrogen. That is the first question. Addition of hydrogen on this reaction. You know that if I add more hydrogen means I am increasing the concentration of hydrogen. So what will happen? The reaction will take place in forward direction to reduce that increased concentration of hydrogen. So the first answer is addition of hydrogen. The reaction takes place in forward direction. Now next is addition of CH3OH, and you can see from the reaction CH3OH is the product. So I am increasing the concentration of product, which means the reaction takes place in backward direction. So the answer for the second one is backward direction. Backward. Now removal of carbon monoxide. Now I am removing carbon monoxide means from the reactant side I am removing carbon monoxide. So now the concentration on product side is more. So what will happen? The product will try to undergo or it gives the backward reaction and we get hydrogen and carbon monoxide gas is produced. So this reaction, if I remove carbon monoxide, then the reaction takes place in backward direction. Now next is removal of CH3OH. We know CH3OH is the product. If I remove CH3OH, there is more concentration on reactant side and forward reaction takes place. So here forward reaction. Now the last is increase in pressure. Now whenever we discuss increase in pressure, first we have to check the number of moles. Now here on reactant side we have 2 plus 1, 3 moles. And product side we have only 1 mole. Now the question is increase in pressure. So if I increase the pressure, then the equilibrium will shift in that direction in which the total number of moles decreases. So here the number of moles decreases in the forward direction, that is 3 mole to 1 mole. So in which direction will the reaction proceed? The reaction will proceed in forward direction if I increase the pressure. So the reaction again proceeds in forward direction. The reaction proceeds in forward direction so that the total number of mole decreases. Okay, so this is about Le Chatelier's principle. Thank you.